Hello. So as a bit of a preamble, this is our first webinar, and we accidentally deleted the main file when we did the original stream of the webinar. So because of that, I'm re-recording it. I would have forgotten some of the stuff I've said. I've got a list of a couple of the questions that came through at the very end. So let's get on with it. So as I said, this was our first webinar, so you can expect it to be a little bit bumpy, really. We've tried our best. We tried out a couple of pieces of new technology, and we decided to try and stream these things on YouTube. We don't want your data, and we just wanted to try and see what we can do and share some of our knowledge that we would give our clients or our friends or some companies that would come speak to us. It's the same kind of knowledge that we give. We just wanted to make it easy for everyone else to access that. So let's see, next one. So our first webinar, we've decided to try and keep this one relatively light touch. We're not going into too much detail. There's nothing heavily specific here. It's very much how we operate at 4C to map innovation. If you have any further comments or questions, feel free to reach out to me, mark@4cdesign.co.uk. And you can either have one-to-one or I can try and create a blog post so everyone can kind of understand some of the questions and answers. So this topic is how you map innovation using technology readiness levels. This is quite an important thing because innovation can be seen as this wild beast, this untameable chaos, where things would sit on people's desks for years and get the occasional tweak before making it into manufacture and making it into the market. So we believe that you have to be quite fast at innovation, especially at the very beginning. And because of that, a lot of large companies out there use technology readiness levels. And technology readiness levels were created by NASA. So unless you're SpaceX, you're probably not trying to achieve the same level of complexity, but they're still completely relevant for doing any form of innovation. And that process looks very much like this. It's a bit of an emotional journey. There's a reason why it's called the fuzzy front end of innovation. It's quite messy, it's quite chaotic. You're basically trying to explore as much as possible, keeping the brief quite open. There is no right or wrong idea. It's all about working on that idea to create the best possible solution for an opportunity that you've identified. One of our clients, when I asked them, what should we do a webinar on, because they're incredibly supportive of some of the stuff that 4C does, they gave me this piece of feedback, and I accidentally forgot to ask him for permission, so I haven't included his name. But they basically said that with innovation, it's going to take longer than you think to get to market. There's a process to it that you need to follow, and there are no shortcuts if you want to ensure the product is fit for purpose before it enters the market. And that is very crucial. It's right. There's no denying it. But it's very hard to say that this is a process. This is a mess. As innovators and designers, it's our responsibility to kind of manage that chaos as much as possible. It's good to have it as a wide open brief at the very beginning because it's cheap. This whole idea of failing fast, it's achievable. This diagram was done by Damien Newman, who for a long time was a researcher at IDEO, and the key principles are there. It's all about keeping that brief as open as possible, where a change in direction isn't going to cost much. And to kind of explain that further, you can use the technology readiness levels on top to try and break up the process a little bit more. So technology readiness levels tend to start from 1 and end at 9. As designers, we always fiddle with processes to try and suit it to kind of how we work. But we added TRL 0, and we did that because TRL 1 is the idea. Now, there's you usually get a lot of ideas, but actually a lot of the work is involved at the very beginning, which is understanding what the opportunity is. As an entrepreneur, you spot an opportunity quite quickly. That's what gets you excited, and that's where you have several ideas out of it, and you progress. That's quite agile. As a larger company, actually, the effort of identifying those opportunities can be a lot of work, and therefore it's quite useful having designers, innovators, and engineers in at that very point, because sometimes they'll identify an opportunity quicker than most. They have an empathetic approach to jobs to be done, so they'll speak to line workers, they'll speak to managers, floor staff, stakeholders, as kind of non-biased third-party contributors. And because of that, what you end up with is an identification of a better opportunity to grow that business. And it means that if you involve them at the very beginning, they can progress quite quickly through the TRL 1 to 3 stage, which should be fast. It shouldn't be a case of multiple years. You can do TRL 0 to TRL 3 within about 3 months, typically. So explaining what the TRLs are and the chaos that ensues, we already mentioned that TRL 0 is the opportunity and TRL 1 is the idea. As you get to TRL 3, you've kind of got tiny test prototypes, something that proves either a mechanism or it's a layout or it's a piece of user experience that you can test with a stakeholder or test in situation. It's not a finished product by any means. It's very much a kind of core element taken out of situation to kind of see, will it work the way you need it to work in order for people to understand it and create good design. And then beyond that is a lot of iterative prototyping, a lot of iterative steps through TRL 4 to 6, where you end up with a looks like, works like prototype. That's quite a long process. You're doing research from all the way through this process, really. You don't stop doing research. You're going from TRL 0 to TRL 9, and you're constantly refining things, constantly tweaking. But it's our responsibility as innovation and design leaders to manage that kind of innovation funnel, and which, funny enough, is in the form of the squiggle. You're trying to narrow down the kind of chaos and narrow down the brief as much as possible, but leaving yourself agile so that if an issue crops up, you can kind of respond to it relatively fast. And I guess the easiest way to explain that is if I could do a quick drawing for you. Ooh, it's interesting, the camera's doing something very strange now. But essentially what we identify with the squiggle is it's always changing. You can't have like that mess like that every single time, and depending on the opportunity and depending on stakeholders, you'll find yourself always down a different journey. Let's see where we go. There we go. So you have that kind of squiggle, but the more innovative you are, the wider this scope is here, and depending on the complexity of the product, you'll tend to find you might find a bit of widening of the scope a little bit further on, and that could be down to manufacturing methods. It could be down to validation and verification on core technology. So you might realise that a route that you've gone down with manufacturing or process, it works really well using prototyping techniques and tools, but the moment you go to manufacture, there are regulations over what materials you can use, danger points, stress loads, and therefore you sometimes have to do a secondary bit of work or bit of exploration and understanding the biggest process for that. From our perspective, we had a mechanical component go out last year where it was held together with friction. And it wasn't until we started to try and take it to the market that we realised we had to change it from a mechanical friction fitting to an ultrasonic welded fitting, which meant that we had to spend a bit more time in development and understanding the forces that are going through this component to design it for that process. So, it starts off quite messy. It should always start messy at this end. If it's not messy, then you're not failing fast, you're not being innovative, you're just being quite iterative with your process. It could be something like changing a colour or something, or changing a basic material. You might have a tiny swivel because it's maybe an unknown material, but it's not quite pushing yourself out there. And then as we come further down, you could end up with technical challenges that push you a little bit further. This tends to happen if stakeholders are pushing down a route. So you might find that you start off with machined metal chassis as a kind of confirmed route. You work with metal manufacturers, and then you decide at some point that actually it's cheaper to injection mold this out of a slightly more responsible material. Well, none of the parts have been designed for that, so therefore you have to go through this process, which means you have to do a bit of testing and kind of challenging with materials to make sure it can actually do that. And sometimes that lowers the cost of the bill of materials and improves the functionality of the product as well. So that shouldn't really happen, and it's our responsibility to try and keep it as far down this side as possible. What we tend to find with this, though, is it's really cheap to change things down there. You're talking thousands, if not tens of thousands, to change around this point, which is kind of your TRL 1 all the way through to probably about TRL 4. When you get to TRL 5 and 6, you're changing something fundamental at that point, because you're not looking at manufacturing methods necessarily. You're looking at core mechanisms, and those core mechanisms, if you change them at that point, you're kind of stepping back to TRL 3 or TRL 4, identifying a new mechanism, pulling them forward, and you're probably looking at tens of thousands, maybe a bit more, about 100,000 or so, to go through that process. And then as you progress through TRL 7 to TRL 8, which is your pre-production prototype and your first run production, you're now changing quite fundamental things. That could be a PCB layout, that could be a tool, that could be a whole manufacturing process or supply line. That's very expensive. Okay. So as I said, it's not quite showing, there we go. As I said, it should be relatively quick to go through the front end of the innovation process and fail fast. The kind of TRLs act almost as a gate, I suppose. You can kind of pair up the TRLs and do these quite quickly. There are processes that do this, such as sprints. Typically we found design sprints to be quite good at not necessarily the front end of innovation, but very much a focal point. So if you have a writer's block or a technical challenge that's quite focused, design sprints work quite well. But there are other processes such as innovation sprints, which are kind of keyed for looking at the opportunity and taking it all the way to the point where you've got concept testing prototypes. And it kind of works not just for physical products, but it also works for things like services, and it works for kind of your digital products, because it's all got the same principle. The process is the same. I know that digital products don't tend to use TRLs from the conversations I've had, but it can and should work with TRLs as well. And we have used TRLs to explain a digital product a few times. So at this point in the webinar, because this is a second recording, as I accidentally deleted the real file, we had a couple of questions. Some of them were about future webinars, so I'll skip those. But there were two kind of key ones that kind of came out of there, which I can remember quite well. Let's see. There we go. So the first one was, can you use TRLs for verification and testing? At what point would you do that? So I feel like at a certain point, your verification and testing, and it was a very direct question, I have to say. It was asking how 4C does verification and validation. What we find is a lot of our clients have all the capabilities in-house to do validation, verification, specifically for the technologies that are being developed. So if it has to work at a certain atmosphere, for instance, they have those chambers set up so they can test it so that it works for their clients and their customers. Or if there's a particular stress load or a working temperature that everything has to work at, they have the full capabilities to do that. It's not to say that we don't do verification and testing throughout all the TRLs, really. It tends to come in around about TRL 3, but we identify what those processes are quite early on. So when we're looking at the opportunity, which is TRL 0, we're looking at, what does this product have to do in order to meet that opportunity. So that could be something along the lines of stress loads. So if we've got something that is carrying a weight and has to do it with a safety factor of, say, 2.5, we'll identify what that load is and we'll build a test rig. And that test rig will act in a way, the same kind of way that the Samsung flip phone tests are. It's, they got into a bit of heat because those tests, whilst proved that the thing can open up 1,000 times or 10,000 times, the phone still broke because it wasn't in a user's hands. We make actually quite wild test rigs, so I'll probably make that as another webinar and introduce you to our mechatronics engineer who designed and engineered a few of those test rigs because they're quite cool. But we do that quite early on, so that when we get to TRL 3, there's something for us to take these crude prototypes to and test to make sure they work. And as we progress through the TRLs, those tests become more complex, more repetitive. So that load of 2 with a safety factor of 2.5, that might work a couple of times, and then the part breaks. Because we're using prototyping methods that are quite crude, we know that once we take it to production, it will probably be fine. So what we're trying to do is reach a certain force. And as we progress through the TRLs, the complexity of the rig becomes a bit more. So it's looking for repetitive strain. So it applies a certain weight, a certain force, drops it, and then reapplies it based on how the product would be used. So in terms of validation and testing, we do kind of like a conference boost here at 4C, and we do that all the way through the TRLs, but we expect that at some point the TRLs will require a bit more, which our clients tend to do. And for things like CE marking, you can't actually do that until you've got first off the production run, which is your TRL 8. And that's because they want to test. You want to test it with kind of the finished materials and manufacturing processes, and sometimes that can take a bit of time. I mean, if we come back to the squiggle, so this. Time's not displayed on here, and I should probably do an updated diagram to show what time's like with the squiggle. But to progress from TRL 0 to TRL 3, as I mentioned, you can probably do that within about 3 to 4 months. If you need internal approval, it depends on how long your approval part takes. An agile company should be relatively fast turnover of a month or 2, but we have noticed that some companies take 6 to 12 months just to approve an opportunity. Never mind actually starting in the work. At TRL 4 to 6, that can take about 6 months maybe, depending on what kind of product it is. If it's a smart product, you may be looking closer to 8, 9 months. If it's a relatively simple product, or a system or service, then you're probably looking at around about 4 months. And then carrying it forward, when you get to TRL 7, when you've got a pre-production prototype, that's kind of considered things like draft angles, assembly process. It's been really refined by that point, and to get to that point, it takes a little bit longer. It could take another 6 months or so. When you get to TRL8, you've got things like tooling times. You've got freeing up of the machines for injection molding, if it was injection molding. And then if you have any tweaks to make, so you get samples back from manufacturers and they're not quite right, then you tweak them, and you do another sample, and you tweak them, and you do another sample. But to do that, you need to free up the tool maker, and then you have to free up the machines again before you can get to TRL9, which is a full production run. You can do production runs at TRL8 and start selling. I believe that what a lot of salespeople kind of say is you shouldn't be proud of the first product you release. It's kind of, you're happy with it, but there's always room for improvement, and that's kind of where you are with TRL8. So this, in terms of scope and time, but to get to TRL6, you could be looking, if you're being relatively fast and agile, maybe about 6 to 9 months. By the time you get to TRL8, you could be looking at another year, depending on what kind of team and what kind of suppliers you're working with. Okay, the next question. How do we help with the squiggle later on? So I feel like I've kind of already answered that, and that's probably because I remembered the question when I was re-recording this webinar. But we tend to help with the squiggle later on by just being quite agile and proactive, I suppose. When we see a challenge start to arise, whether that's a kind of delay in a shipment, or there's an opportunity to use an off-the-shelf part instead of having to re-engineer and create our own thing, we'll look out for that proactively throughout a process or product. And that's all about managing the squiggle. So making sure that there will probably be a small squiggle at the end, but it's not ginormous. It's not a case of scrap all the tools, let's start again. It's very much a case of we've got to change the material. Do we need to change the tool a little bit to accommodate shrinkage, or there's more wear on a friction surface than we intended. Let's look at 5 different other materials that might wear less, or how do we improve the tolerances of something. It shouldn't be a fundamental squiggle. It shouldn't be something that's so drastic it costs a huge amount of money, and that's if it's done properly. So when you're working with a good design or innovation team or lead, when that squiggle's been kept quite small, and you're getting product on the market that stakeholders are really excited about, which is something that here at 4C we tend to try and achieve every single time, and so far I believe it's happened. So that's how we deal with the squiggle. Sometimes companies do come to us actually with that squiggle happening at that point, and when you feel like things aren't quite working out right, it's not necessarily a case of just stopping. It's a case of reviewing it and finding a non-biased party that can look at the product you're trying to make, the opportunity you're trying to take advantage of, and kind of do the two marry up. And that could be something along the lines of the bill of materials is too expensive, or you designed a physical product, but it probably should have been a digital product. That's quite a big, change in direction. But yeah, that's something a couple of companies have come to us with, and it's to act as the kind of non-biased party. Okay, I think that's pretty much it. So, because this is our first webinar, and as already admitted several times now, we've had to re-record it because I deleted the file. I guess it comes down to how can we improve. Now, this could be anything from replacing the host, which is myself, which I wouldn't blame you, recording it the first time around and not deleting the file. That's also a benefit. But if you see that there's kind of any room for improvement with these webinars, or there's a particular topic that you want to discuss, then let us know. My email is right at the very beginning, and we'll try and do our best to kind of tailor the next webinar towards that one. We're going to be trying to do these webinars on a fortnightly basis on a Thursday, around about lunchtime, so that if you want to kind of tune in and as part of your lunch hour, or we will hopefully record all the future ones that you can watch them in your own time. But if there's any further questions about the topic, feel free to reach out. and we'll respond. Okay, thank you.